So let's illustrate the idea of a dimensional analysis with a problem that will solve in a way using the definition of multiplication, and then we'll use that solution to try to motivate the idea of dimensional analysis. So a bag of oranges weighs 2.5 kilograms. What's the weight of the bag in pounds? So in other words, we want to convert 2.5 kilograms over to pounds. These are the types of problems that we solve with dimensional analysis. We're trying to convert from one unit like kilograms to another unit like pounds. And so in order to solve this problem, we're going to use a fact that 1 kilogram is 2.2 pounds. And so let's draw a little picture of this piece of information. This box here represents 1 kilogram, which is the same as 2.2 pounds. So we can think of this box as like being one group that contains 2.2 pounds. Now if I have 2.5 kilograms, well then I've got one box, two boxes, and another box. And so according to our meaning of multiplication, I've got 2.5 groups. Each one of these groups contains 2.2 pounds. So take the number of groups times the number of items in a group, and I get the total number of items. And so in the end, we really solved this problem by taking 2.5 times 2.2, and if we do that arithmetic, we get 5.5 pounds. So there's the solution to our problem. But now let's look at that solution in a different way. And so to start, we're going to take this piece of information that 1 kilogram is 2.2 pounds and write that as an equation. 1 kilogram equals 2.2 pounds. Now notice that in this equation we got units, and we put label on our units there. We're not saying that 1 equals 2.2. We're saying that 1 kilogram equals 2.2 pounds. So our labels here are very, very important. Otherwise it'll look like we're saying something that isn't true. So now if I do a little bit of algebra here, if I divide both of these sides by 1 kilogram, then on the left I get 1 kilogram, and on the right I get 2.2 pounds over 1 kilogram. So this fraction here equals 1. So now let's apply this observation back to this equation here. So I could think of this multiplying 2.2 right here as really like multiplying by this fraction 2.2 pounds over 1 kilogram. And so to solve this problem, what I really did was take 2.5 kilograms times 2.2 pounds over 1 kilogram, and then notice how it kind of looks like our units cancel off. I've got a kilograms here in this numerator, a kilograms here in this denominator. They're the same, and so they cancel out. So I get 2.5 times 2.2, and then the label that's left is pounds, and so I get my 5.5 pounds. So this is kind of the way dimensional analysis works. We start off with a problem where we want to convert from one unit to another unit, and in the end what we do is we take our original quantity and we multiply it by some fraction that equals 1 in such a way that our units cancel, leaving the units that we want. Now let's look at another problem that we saw earlier on in the semester and illustrate how kind of the same dimensional analysis idea is involved. So in section 6.1 and 6.2, when we first talked about division, we saw this problem. 1 gallon is 16 cups. How many gallons are in 64 cups of lemonade? So here's the picture that we drew for that problem. We're going to take our 64 cups. 16 of those cups is going to go to our first gallon, another 16 into our second gallon, and we'll keep going until we run out of cups of lemonade. And so from this picture we see that this is a how many groups type of problem that we'll solve by taking the number at the top, divide it by the number in the middle, and we get our answer of 4 gallons. Now let's look at another way that we could write our solution. Instead of dividing by 16, we could also multiply by 1 over 16. And now where does that 1 over 16 come from? Or let's look at another way that we could have gotten that fraction 1 over 16. So we're told in our problem that 1 gallon is equal to 16 cups. And so if we divide both sides of this equation by 16 cups, we get 1 gallon over 16 cups equals 1. So again, we've got a fraction here that equals 1, like in the previous problem. So now if I go back to this version of the solution, I could think of this as taking 64 cups times the fraction 1 gallon over 16 cups. And then again, notice that we've got cups here in the numerator, cups there in the denominator. Those cancel off, and so the units that are left are gallons. We've got 64 times 1 over 16, which is the same as 64 divided by 16, and either way we think about it, we get 4 gallons. So here's another problem that really involved converting cups to gallons, and we did it in the end by multiplying the original quantity by a fraction that equals 1 in such a way that our units cancel, leaving the units that we want. So that's the basic idea behind dimensional analysis. When we use dimensional analysis, the goal is to convert a given quantity to different units. And the basic steps are that we multiply the original quantity by a fraction equal to 1 in such a way that the original units cancel, leaving the units that we want. So if we write down our work very carefully, we should see that units cancel to get rid of the units that we don't want, and what's left should be the units that we do want. So let's illustrate this idea of dimensional analysis with a couple of other examples. Let's convert 2 square feet over to meters squared. So a couple of pieces of information that we'll use. First of all, that 1 foot is equal to 0.3048 meters. Another is that square feet really means feet times feet. The third is that square meters really equals meters times meters. Okay. And so let's take this first piece of information, that 1 foot equals 0.3048 meters. And if we divide both sides by feet, we get that 1 is equal to this fraction. And so having a fraction equal to 1 is a very important step in dimensional analysis. So now, if we take our original quantity, 2 square feet, I'm going to multiply by that fraction twice. And notice when I do that the first time, this unit of feet here cancels with one of these units of feet there. And then when I multiply again, that unit of feet cancels with the other unit of feet that I have there. And so the units of feet cancel off, and I'm left with meters times meters, which is meters squared, which is exactly what I want. So then the arithmetic I need to do is 2 times the 0.3 times 0.3. And if I do that arithmetic, I get 0.1858 square meters. So there's an example of using dimensional analysis. Now here we had to multiply by the fraction twice, but that's okay. In our last example, we're going to convert 25 meters over to yards. Now this problem is going to require 4 pieces of information. The first is that 100 centimeters is equal to 1 meter. Second is that 1 inch is equal to 2.54 centimeters. Third is that 1 foot is 12 inches. And the last is that 1 yard is equal to 3 feet. So let's look at the arithmetic that we would do here and talk about why this works. So we're going to start with our original quantity, 25 meters. Now we're going to multiply by 100 centimeters over 1 meter. And when we do that, we see that meters cancel, and I'm left with centimeters. Now that's not the final unit that I want. So we're going to multiply by 1 inch over 2.54 centimeters. And when we do that, centimeters cancel, and I'm left with inches. Now inches is not what I want. So I'm going to multiply by 1 foot over 12 inches. And notice that inches cancel. I'm left with feet. Feet is not what I want. So I'm going to multiply by 1 yard over 3 feet. And notice that feet cancel and I'm left with yards. And that's exactly the unit that I want. So now the arithmetic I need to do is 25 times 100 times 1 over 2.54 times 1 over 12 times 1 over 3. And I get 27.3 yards. I could have also thought about this as 25 times 100 divided by 2.54 divided by 12 divided by 3, and I would have gotten the same answer. So there we have it. 25 meters is equal to 27.3 yards. Now you may be asking yourself, how did we know to do it this way? How did we know that I'd have to use these 4 pieces of information and put those together in this way? Well, the answer is we really didn't know that at the beginning of the problem. We just started with what we were given, 25 meters. And then remember that we want to multiply it by something that equals 1 in such a way that units cancel, leaving the units that I want. And that's exactly what we have. Now we had to do lots of steps in order to get the units that we wanted in the end. But everything canceled off exactly the way we wanted. Yards was left in the end, and so it all checks out in the end. Sometimes in math we don't know exactly how to solve a problem at the start. We've just got to start with what's given, use some ideas that we already know, and then in the end take a step back and check did it all work out. If it did, great. If not, then you've got to try something different. So that's it for this section. Your assignment is to read section 11.4.